Hi, I'm Yoav Weiss. I work for Akamai. I work on browsers and web standards. And as a member of the Web Performance Working Group, I'd like to tell you a bit about the work that we do, and mostly how it impacts your life. How can you use the work that's being done in the Web Performance Working Group to make your sites faster, your users happier, and hopefully make your lives a little bit better as a result? So first, what is a working group? Since I'm guessing most of you were never involved in web standards, some of you may have a mental image of a working group as a group of the industry's elders sitting in our ivory towers and making decisions for the commoners out there. But reality is quite different. We're basically just a bunch of engineers interested in performance working on browsers as well as large websites. And we have members from companies from across the industry, such as Google, Microsoft, Facebook, Twitter, Apple, Akamai, and others. We meet up online every couple of weeks. We meet up face-to-face once or twice a year. And the bulk of the work that we do happens between those meetups and GitHub repos and issues. As you can understand from the working group's name, our work is focused on making sure that you can easily optimize your sites and make them as fast as they can be. So what have we been working on? In the last few years, we worked on several APIs that were mostly focused on a couple of performance-oriented goals. Can I get one slide back, please? Thank you. The first goal is measurement. The first set of APIs is there to make sure that you can measure your site's performance in the wild. You cannot speed up what you can't measure. And being able to track real-life users and real-life performance of your website is critical to improving it. Dev tools as well as web page test are both tools where you can get a lot of useful performance info, and both are great. But getting that same level of information from real users is invaluable. There's a limit to the number of devices, networks, and user scenario you can test on in your labs. And getting performance data from users gives you great insight into how your site is actually being used and what your performance bottlenecks really are. The APIs we use for measurements include navigation timing, which enables you to measure the current page's loading metrics. Resource timing, which enables you to get very similar data on a per resource basis. User timing, which gives you the ability to measure critical points in your application logic, so you can create your own JavaScript-based metrics. And Beacon enables you to send all that data back to the server in a performant and a reliable way. Now, I went over the list of APIs, but those of you who are not familiar with them may not have a clear view of what they do and how you can use them. So let's look at an example. Say that I have this site. I want to know how fast my site is loading in the wild, but in particular, I want to know how fast users are clicking on the conference buttons, which are my main call to action. How can I measure that? Well, first, I can use navigation timing in order to figure out the important milestones in my page's loading phase, including the time to first byte for the HTML, how long it took us to get to DOM content loaded, which in many applications is an important event because a lot of JavaScript functionality tend to be hanged on that event. And then I can also measure how long it took for DOM content loaded event handlers to actually run. Then I can I can use resource timing in order to dive deeper into pair resource analysis and, for example, figure out which resources have finished loading before DOM content loaded fired, and gather them and send them back to the server, because these resources are likely to also be the ones stalling DOM content loaded. So if they are slow, the event itself triggers later. I can also gather all the resource data and send it all up to the server for later processing. Then I can use user timing in order to mark an event whenever a user has actually clicked on one of the buttons that I'm interested in. And finally, I can use the beacon API when the page is changing visibility in order to send that data back to the server. And the advantage of using beacon there is that it continues to send up that info to the server even if the user has navigated away from the page. Then, once I have all that data back up on the server, I can see how long it took for users to actually click on my call to action buttons. I can correlate that data with other site metrics, use the resource timing data in order to create dev tools like network waterfalls, and analyze the ones that are particularly slow in order to figure out which resources are slowing me down. I can test how the conversion speed of users clicking those call to action buttons. I can test how it changes if I move the button up and down or change the way it appears. Basically, A/B test our conversion speed and match all those metrics up against our conversion rates and see if they're related. Chances are that they are. And finally, I can use all that data to figure out my performance bottlenecks and then try to solve them. How can I solve my performance bottlenecks? That's the second set of APIs, which are hinting the browser about what's about to happen so that the browser can better prepare for it. The two major hints I'll talk about are pre-connect, which enables us to tell the browser about a third-party host that it's going to need to connect to, and enable the browser to connect to it ahead of time. So establishing, send out a DNS query, as well as establishing a TCP connection and then a TLS connection. Taking all that part from, saving all that part from the time that the resource will actually be needed. Preload enables us to do the same, but also download the resource ahead of time. And by using those hints, by using pre-connect and preload, you can help the browser discover those resources earlier and have them ready by the time they're actually needed. And if you're interested in pre-connect and preload, I'll talk a lot more about them at 11:50 today at G102. Okay, so I hope that clarifies the work that we've done, but potentially more interesting is what the work that we're about to do. What are we working on next? One thing that's missing from current metrics, and one thing that DevTools and WebPageTest give us, is visual metrics. Both DevTools and WebPageTest give us insights as to how our page looks as it is loading. WebPageTest goes a step further and gives us a score called Speed Index, which indicates the visual progress of your site towards it being visual complete. RUM does not have that today, and this is one thing that we're working on. There are a couple of new proposed APIs that called First Paint and First Contentful Paint that basically give us the time it took for the user to see something on screen. First Paint is mostly focused around background paints. First Contentful Paint is focused on actual content being painted to the screen. In some pages, the two will be identical. In other pages, there may be a significant difference between the two, depending on your site's architecture. And first meaningful paint is a metric which we tried to achieve and try to define some standard way to get to. But it turns out that it is very hard to define a heuristic for what's meaningful in a standard way that is implemented across browsers. So instead, we decided to explore something called the Hero Element API. That API enables you to declare a certain element so that its painting would be registered as a sort of a user timing event. Because the user timing API I showed you earlier is only for JavaScript-based events. So you cannot apply it to elements that are just drawn on screen as part of our HTML. The Hero API enables us to do that and apply custom metrics to a significantly larger set of use cases. And in a way, allow us to determine our own first meaningful paint for our website. Another area that needs more attention is runtime metrics. And there are two interesting new proposals on that front. The first is long tasks observer, which indicates that the browser's main thread has been busy for over 50 milliseconds doing some JavaScript layout work or some other internal work. But basically, it means that our user's browser is unresponsive during that time. So we should take note and try to figure out what's slowing us down in that particular user scenario. The other API is input latency, which is there to indicate that the user actually tried to interact with your website and saw a significant lag in operation because the browser was busy doing something else. All those proposals are still early proposals, but they're on their way to be implemented and shipped in browsers. And hopefully will be part of your performance toolkit a few months from now. The last thing I want to talk about is how you can influence the direction in which we're going. Like I said at the beginning, we're not sitting in our ivory towers, but many of us are working for large companies, working on browsers or very large sites, and we don't necessarily know all of your day-to-day struggles with performance, which is why we need your help. We need your feedback. All the discussions on these proposals happen on GitHub repos and issues. New proposals are being discussed and worked on as part of the Web Platform Incubator Community Group, which I'm co-chairing. And they're being discussed mostly on our Discourse instance or as part of GitHub issues. And we've put all the tools in place in order to make it as easy for you to participate as possible. So my request to you is go to check out those new proposals on the WICG's Discourse. Watch repos for proposals you care about. And above all, don't be afraid to provide us with feedback regarding those proposals. If they are great and they're everything you ever dreamed of, we want to hear it. If they won't help you one bit, we want to hear it even more. So please, get involved. And in the immortal words of Jerry Maguire, help us help you. Thank you.